Many of you might have heard about the Chemistry Nobel Prize winners for this year, Emmanuel Charpentier and Jennifer Doudna, for their pioneering work in CRISPR gene editing. First off, congratulations to them, not only for their research, but also for being the first female-only team to win the Nobel Prize for Chemistry. Go women!
Their research and creation of CRISPR-Cas9 gene editing has the power to eradicate diseases, substantially improve plant growth, and also design an embryo. But we can get to that later. To start with, what is CRISPR?
CRISPR stands for regularly interspaced palindromic repeats, and it is a system of molecules that allows modification of gene sequence by cutting, repairing, editing, or deleting specific DNA sequences.
This technology involves two main components. The first is the Cas9 nuclease, which is also known as the proteins, and the second is the guide RNA. The guide RNA is artificially constructed and is used to guide the Cas9 nuclease to the area where the cuts are to be made. And once the cuts are made at the site, there are two routes that the process can take. The first is to allow the cell to repair itself, but in this step, the gene function is usually stopped. The second involves adding a DNA template, so when the cell repairs itself, it follows the DNA template and gene function is maintained.
So, how did it actually come about? Well, Charpentier identified another key component of the CRISPR system, an RNA molecule that is involved in recognizing patch sequences, which can cause diseases in humans. In 2011, she reported this discovery and struck up a collaboration with Doudna. They isolated the components of the CRISPR-Cas9 system, adapted them to function in the test tube, and showed that the system could be programmed to cut specific sites in isolated DNA.
So why was it worthy of a Nobel Prize? When investigating the effect of DNA on human diseases, scientists must work out which gene sequences were responsible for the disease. It is economically and physically consuming to find this out using the previous methods, such as zinc fingers, which costed more than $5,000. In fact, it includes so much work that Bruce Conklin, a geneticist at the Gladstone Institute in San Francisco, says it was a student's entire thesis to change just one gene. Compared to that, CRISPR only cost $30. The introduction of CRISPR was so revolutionary as it quickly overtook the use of zinc fingers and other gene-modifying techniques after its introduction. It is considered as one of the biggest scientific developments together with PCR. This was also important due to the fact that this was the first Nobel Prize for Chemistry awarded to women without crediting another man. It shows progress in the scientific field with relation to gender discrimination.
For starters, in 2014, Daniel Anderson, a bioengineer from MIT, and his colleagues used CRISPR with mice to modify a mutation which causes a metabolic disease called tyrosinemia, a disease that occurs in humans as well. It is also planned to be used to modify gene sequences in disease-spreading mosquitoes, which could help control diseases such as malaria. It could possibly eliminate the entire mosquito population. In November 2018, Chinese biophysicist He Jiankui announced that twin girls had been born from embryos that he and his colleagues had edited using CRISPR-Cas9. Biologists have also used the CRISPR system to store a short 5-second movie inside of the bacterial E. coli DNA.
It is generally agreed upon that the use of the CRISPR technology is ethical when it comes to eliminating diseases and doing further research into the molecular mechanisms of diseases, but the concern comes when the technology is used for enhancement. So embryonic enhancement holds great power. In the future, the possibilities are endless. This technology could be used to edit the genetic material of babies to make them more smart, to make them more attractive. Virtually any characteristic could be enhanced. Now, while this seems to be ideal, would it also not take away from an individual's personality and uniqueness? In countries like India and other Middle Eastern countries where the baby boy is preferred over the baby girl, it could also further enhance the disparity between preference of the two genders and exacerbate the gender imbalance. And of course, as this technology is more expensive in regards to the editing of a baby's genome, it would mean that only the very rich could afford it. And this, again, is quite unethical.